Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 7 from the February-March 2023 International A-Level. This is the Cambridge 9709, paper 4, variant 2, mechanics. The diagram shows a smooth track which lies in a vertical plane. So it's a smooth track and this is a vertical plane. So high, it's up, it's down. The section AB is a quarter circle of radius 1.8 meters with center O. The section BC is a straight, horizontal straight line of length 7 meters. It says OB is perpendicular to BC. That's 1.8 meters. So that's basically vertically, the vertical height of O to B is 1.8. They're trying to say there. The section BC, the section CFE is a straight line inclined at an angle of theta above the horizontal. A particle P of mass 0.5 kilograms is released from rest at A. So particle P is released at rest from A. Okay, so it's at 0 meters per second. And it collides with a particle Q of mass 0.1 kilograms, which is at rest at B. So you have another particle at rest at B. This is particle Q. Okay, so this one is 0.5 kilograms and this is 0.1 kilograms. Okay, immediately after the collision, the speed of P is 4 meters per second in the direction BC. You should assume that P is moving horizontally when it collides with Q. Show that the speed of Q immediately after the collision is 10 meters per second. So the speed of P after the collision is 4 meters per second. The speed of Q we have to show is 10 meters per second. All right, so let's draw a little diagram here. So we've got basically, let's draw a diagram of when P hits Q at B. So this is at B. That's P hitting Q. P and Q. P is a mass of 0.5 and Q is a mass of 0.1. So here we have 0.5 and 0.1 kg. P is moving with a speed before the collision. Okay, so we don't know what it is moving. So we don't know what the speed of P is before the collision. The speed of Q before the collision is 0. The speed of P after the collision, they've told us, is 4. And we have to show that this is what we have to find. We have to show that this is equal to 10. All right. So what we need to do, we need to know what the speed of P is as it hits Q. For us to be able to use the conservation of linear momentum, we need to know what the speed of P is as it hits Q, and we can use the fact that we have the conservation of momentum of mechanical energy. So we have this level and we have this level. So we can work out the kinetic energy at A and the potential energy at A. The kinetic energy at A plus the potential energy at A is equal to the kinetic energy at B plus the potential energy at B of the particle P as it moves down. Okay, and P, as we said, has a mass of 0.5 kilograms and it starts at A at 0 meters per second, and we want to know what speed it reaches by the time it reaches B. Okay, so we can use the conservation of energy. So the kinetic energy of this particle P at A is going to be, remember, the kinetic energy is equal to a half mv squared, and potential energy is equal to mgh, where h is a vertical height. So we can say a half mv squared. Well, we can say 0 because the velocity at the top is 0. So we can say 0 plus its potential energy, which is its mass, which is 0.5 times g, which we're going to call 10 because we're in Cambridge here, times h, which is 1.8. That's mgh. That's the potential energy. That's kinetic energy at A must equal the kinetic energy plus potential energy at B. So you're going to have a half times the mass, which is 0.5 times v squared, which is what you have to find, plus we're going to call this is where potential energy is equal to 0 at this level. Therefore, the mgh will be 0. Okay, so we have this equation we can now solve. So we're going to have 1.8 times 5 by times 0.5. That's 0.9 equals, is that right? That's 5 times 1.8. Let's have a look. You're going to have 0.5 times 10, which is 5 times 1.8, gives you 9. Okay, so it's actually 9, sorry. My bad. Okay, so that's 9. Okay, so you have 9 equals a half times a half, which is a quarter v squared. So you have a quarter v squared, so you're going to have 36 equals v squared. Therefore, v is equal to 6. Okay, so we know that this is 6 meters per second when it hits, when it when it reaches here is going to be 6 meters per second. So now we can use the conservation of linear momentum. Okay, conservation of linear momentum. We can think of what's happening before the collision and what's happening after the collision. And we know that the total momentum before the collision is the mass times the velocity of A plus the mass times the velocity of B before the collision, and that must be equal to the mass times the velocity of P after the collision, which is 0.5 times 4, plus the mass times the velocity of B after the collision, which is what we have to find. So we're going to have 0.5 times 6, which is 3, plus 0 equals, that's 2 plus 0.1 VB. Okay, so we're going to have 3 minus 2, which is 1, equals 0.1 times the velocity of B. So 1 divided by 0.1 is like 1 divided by a tenth, which is going to give me 10 meters per second. And that is exactly what we had to show. Okay, so there's part A completed. All right, so that's part A done. Okay, now we're going to go on to part B. All right, it says when Q reaches C. All right, so we had P coming down. Now P is over here. After it's collided, P is moving. Okay, let me just draw it a bit bigger so we can. So I'll draw it down here so we can see it better. So P has reached here. P is 0.5 kg. It's now moving with a speed of 4 meters per second. Okay, Q is now moving along. Q is 0.1 kg and it's moving with a speed of 10 meters per second. Okay, that's Q. Right? So that's moving along. Now, when Q reaches C, it collides with particle R. So there's a particle R here, which has a mass of 0.4 kg, which is at rest. Okay? So the two particles coalesce. The combined particle comes instantaneously to rest at F. Okay, so you should assume that there is no instantaneous change in speed as a combined particle leaves C. Okay, nor when it passes through C as it returns down the slope. Given that the distance CF is 0.4 meters, find the value of theta. Okay, so let's have a look at the situation now. You've got these particles. This is going to collide. Well, that's finished now. These two are going to collide. Okay, so you've got Q and you've got R, and then you've got afterwards Q and R together. Q and R. So you got Q and R, which is, this is 0.1 kg, this is 0.4 kg, this is at rest, this is going in this direction 10 meters per second. Q and R together coalesce, so they become one particle, 0.5 kg, and I want to find what speed this starts going up with. All right, I need to know that speed. Okay, so I need to find what this v is. So again, by the conservation of linear momentum, this is what's happening before the collision, and this is what's happening after the collision. So before the collision, you have the mass times the velocity, the momentum, mass times the velocity of Q, plus the mass times the velocity of R, which is 0 because its speed is 0. Okay, after the collision together, they may have a mass of 0.5, and the velocity is what we have to find. So this is going to give you 0.1 times 10, which is 1, equals basically a half v. So therefore, v is equal to 2 meters per second. So that means when this combined particle is moving up to F, it starts off with a speed of 2 meters per second. And we know that the distance CF is 0.4 meters. So what I'm going to do is I'm going to make a little diagram here just to make it a bit clearer. So we have here the combined particle, okay, which is QR. So I'll call it QR. I know its mass is 0.5. Its speed as it's going up the slope starting at C is 2 meters per second. Its speed when it reaches F is, of course, 0 meters per second. It comes to instantaneous rest. Okay, the distance between C and F, as we're told in the question, the distance between C and F, as we're told in the question, is 0.4 meters. Okay, so that's 0.4 meters. I'll put that a bit higher up there, so some more space here to work. So that distance is 0.4 meters. We know the angle made with the horizontal here is theta. Okay, and what else do we know? Okay, now what I can do here, we also know, what do you know about theta? Anything about theta? We have to find theta. We have to actually find theta. Okay, so we have to find what theta is. Now, what I think we can do here is, I think the best way to deal with this is to use, again, energy. Okay, so I can say that if I call this the place of zero potential energy, so this is a level of zero potential energy, and then I got the level of F. Okay, so we got, this is where potential energy equals 0. So that's the level of C, and that's the level of F. So what we can say is that the kinetic energy at C plus the potential energy at C is equal to the kinetic energy at F plus the potential energy at F, okay, the level F, right? So we need to understand, we need to find what this height is, okay? That will help us. And can we find that height? That's 0.4. Let's have a look now. Okay, so the kinetic energy at C is going to be a half times m, which is 0.5 times v, which is 2 squared. Okay, that's a half mv squared. And the potential energy at C is 0. The kinetic energy at F is 0. And the potential energy at F is m, which is the mass, 0.5, times g, which is 10, times h, which, see, we can find h with this. You see, now we can find what h is, and that will help us to find theta. All right, so this is a half times 4, which is 2, times 0.5, which is 1, equals, right, that's a quarter times 4, yes, 1 equals, and this is going to be a half times 10, which is 5h. So therefore, h is equal to 1 over 5, which is 0.2 meters. So this is 0.2 meters. So we found the height using the conservation of mechanical energy. All right, and now, because that's 0.2 meters, and this is a right angle because it's a vertically high, we can say that the sine of this angle theta is equal to the opposite, 0.2 over, this would be the hypotenuse, 0.4. So the sine of theta is equal to a half, and we know that inverse sine of a half will give us 30 degrees. You can use a calculator, but you should know that anyway. So we have shown, or we have found the angle theta, and that was part B of this question. So part B is done now. And now we can go on to part C. It says, find the distance from B at which P collides with the combined particle. Whoa, this looks a bit involved here. Okay, so let's have a look. Let's try and figure this out. So P, remember, was the particle that hit the particle Q, okay, at this stage. So at this stage, P hit Q. Okay, P hit Q. And it was traveling at 4 meters per second after the collision. Okay, Q ended up here. Okay, and it combined, it ended up there. So Q had two things happening. First of all, it went from B to C at a speed of 10 meters per second. That's the first thing that happened. Then after that, Q combined with R, QR, and it went up the hill up to F, and then came back down the hill, back down to QR. So it started off its journey up the hill going at 2 meters per second. It went to 0, and because there's no friction, it's ended up coming back down at 2 meters per second. So when it comes back down, it's going to be rolling this way at starting off at 2 meters per second. So because this is smooth, it's going to continue at 2 meters per second this way, and P is going to be going at 4 meters per second the whole time until it hits this combined particle as it's come back down again. So that's what's going to happen. So P hit Q, Q went all the way there, it hit R at that point, went up the hill, came down again, rolled along, P was carrying on moving, they're going to hit again. So what we need to determine here is, first of all, how far has P moved? Okay, how far has P moved at the point that Q has reached this point over here? Then we can work out what's remaining for them both to cover, and we can work out the place where they will intersect, or they will not intersect, they will collide. So there's a few things to do. So the first thing we need to work out is how far did P move, okay, in the time that Q got from B to C. So we need to find the time that Q moved from B to C. The time for Q moving from B to C. Now, we know that it moved a distance of 7.0 meters, and we know that it was going at a speed of 10 meters per second. So we know speed equals distance over time. So time is equal to distance, speed is equal to distance over time. So time is equal to distance over speed. So it's 7 over 10, which is 0.7 seconds. So it's taken 0.7 seconds for Q to go from there to there. Now we got to work out how much time Q took to go up to F and down again, because P is going to be moving, that whole time at that constant speed. So we got 0.7 seconds, it's been 7 seconds P has been moving for, while Q reached this level here. Now Q is going to go up this hill. Okay, now its speed is now going to be 2 meters per second when it goes up this hill. So the second thing is we've got to find the time it takes from Q to go from C to F back to C again. Okay, C to F back to C again. So what we could do here actually is we could find out how long it took to get to F. Okay, and then double it, because it's going to take double the time to come back down again, right? So let's have a look. Let's see what we have. Let's see what we can do Subat. So we're going to see, first of all, let's find C to F. So we have S, U, V, A, and T. So S is, we know it's 0.4 meters. It traveled up from C to F. U is 2 meters per second. V is 0 because it came to rest there. A, we don't know A. We can find A actually, but do we need to find A for this? V squared equals U squared plus 2AS. In fact, we can find A using this. Okay, hold on. We can find what we need, which is the time, using something else. We know that S equals U plus V over 2 times T. That's one of the equations of motion based on the trapezium rule, right? So I want to find T. I know U, I know V, I know S. So I can find the time this way. So we're going to have 0.4 equals U plus V, which is 2 over 2 times T. Okay, so T is going to be 0.4 seconds from C to F. So C to F back to C again is going to be 0.4 plus 0.4, which is 0.8 seconds. 0.8 seconds. So therefore we can say that Q has been moving. Okay, so Q moved for 0.7 plus 0.8, which is 1.5 seconds from going from B to C to F back to C again. Okay, so now Q has reached this point. This is a bit of a tough question. I think, is it the last question of the paper? It probably is. That's how they normally give them. Sometimes you don't even get time to finish, but it's a bit of an involved question. So, but it's doable, but it's going to take some time. So you got Q here after it has gone through this journey. Okay, so this is the time that it's reached. This is 1.5 seconds after it was hit by P. Okay. Now we got to find how far has P come along. Okay, this distance from B. Okay, so now P has moved along here for 1.5 seconds at a speed of 10 meters per second. So how far along did P move until this stage? Which it's not going to be the final answer still. So P has moved, okay, this distance in 1.5 seconds. So we know that speed equals distance times time. So speed equals distance over time. So the distance he's traveled is his speed times his time. It's a constant speed. So 10 times 1 point. Sorry, the speed is not 10. My bad. Remember P, its speed was 4, right? P, the speed of Q was 10 when it was moving, but P hit Q and P went off of 4. So sorry about that. So the speed of P is actually 4. It's been moving 4 meters per second. Okay, so it's 4 times 1.5, which is 6 meters. So this is 6 meters. So from B to this point, it's moved 6 meters. Now, we're going to figure out what to do here. I know that Q is moving. I know that, sorry, this is P. I know that this is P and this is Q. I know that P is moving at a speed of 4 meters per second this way, and Q is moving at a speed of 2 meters per second this way, and I want to find where they meet. Okay, there's going to be a certain distance at which they meet. Of course, it's going to be closer to Q than P because this is moving faster. All right, and I can work this out quite easily by ratio because this is going twice the speed, so it's going to cover twice the distance. So the ratio of this is going to be 2 to 1. Okay, 2 to 1. And what's left here is 1 meter. This is 1 meter left. Okay, because the total distance was 7 meters, right? So 6 meters being covered, that's 1 meter left. So that 1 meter is going to be divided in the ratio 2 to 1. And P is going to have moved 2/3 of that. So it's 2/3 times 1, which is 2/3 of a meter. So the distance from B to the place of the collision, we can say B to the collision, the distance is going to be 6 plus 2/3, which is 6 2/3 meters. Okay, now if the numbers weren't so friendly here, we could have done this in a slightly different way. We could have said, for example, let's call, I'll show you an algebraic way of doing this as well. The numbers are friendly because they're double, so the distances will be double what the other way around, because the one that's moving faster will cover double the distance. But if the numbers weren't so friendly and you weren't sure what to do in that sense, we can do an algebraic method here. So I could take that distance as being, we know that that's 1 meter, the total distance. We could say, for example, let's call this x because we want to find that distance. And therefore, this is going to be 1 minus x. So I know that speed equals distance over time. Okay, so we know that distance is x. Okay, and we know the time is the same. So the time is the distance over the speed. So when you know that they're going to reach this point at the same time from when we're considering when they've reached these two positions. So the times that they're going to be moving are the same. So the distance over the speed for this one will be the same as the distance over the speed for that one because the times will be the same. So the distance he's traveling is x over his speed, which is 4, and that's going to be equal to, that's the time that he's taken to get from here to there. That will be the same time that it takes to get from there to there. So he's traveling a distance of 1 minus x. He's going at 2 meters per second. So his distance over his speed is given by this. So if we cross multiply, we'll have 2x equals 4 minus 4x. So we end up with 6x equals 4. So x equals 4 over 6, which is 2/3. So x is 2/3, as we deduced from ratios. But either way, you get the answer. So then you add that to the 6. So the total distance that the particle from B at which P collides with a combined particle is 6 2/3 meters. Now that is a very involved question. It takes a long time and there's a lot of thought involved in it. It's a bit of a cruel question, to be honest. I must, if I say so myself. But that's how things go. You manage to get that in the exam, and everything else, for sure, you'll get an A star. I'm sure if I read the examiner's report, not many people will have answered the question for this. But anyway, this was the February-March 2023 paper. So other questions from this paper, when I've answered them, I will put them in the playlist, which will appear in this section over here of the page. Other questions dealing with this topic, which is to do with linear momentum. So I'll have my momentum playlist over here. It's also to do with work energy power. So I'll put that playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.